Hi, so today we have a question from chapter 8 in physics, which is number 8.102, which is one of the big questions. So let me read the question. A thorium nucleus at rest decays to a radium nucleus with an emission of an alpha particle. The total kinetic energy of the decay fragment is 6.54 times 10 to the negative 13 joules. The alpha particle has 1.76% of the mass of the radium nucleus. So we have two parts to calculate the kinetic energy for the recoiling radium nucleus and the alpha particle. So to try and solve this question, we need to get an equation. We need to try and derive an equation for the numbers that we have. So as you can read in the beginning, that the nucleus at rest decays. So by that, the momentum equals to 0. So conservation of momentum is going to be equal to m a v a equals m b v b. So by a and b, a I mean alpha particle, and b is the radium nucleus. Okay, so now we need to solve for the radium nucleus velocity because we don't have that. So VB equals MAVA over MB. Okay, so one of the formulas of kinetic energy is that Ka plus Kb equals Q. And Q is the decay fragment that we have right here. So the sum of kinetic energy equals that decay fragment. So we know that the kinetic energy equals 1 over 2 mv squared. So this is going to be MAVA squared plus 1 over 2 mb. So for the v, we just derived this from v. So instead of using v, we're going to use this equation that we got out. So it's going to be v squared VA squared times MA over MB squared. Just took the VA squared outside to make it easier to calculate. And this equals to Q. Okay, now as you can see, we have a lot of common factor. We can get a common factor out of the left side. So as you can see, we have 1 over 2 MA VA squared and MB. So 1 over 2 MAVA squared. So 1 over 2 cancels 1 over 2. MA with the square of MA, VA squared with VA squared, and MB with 1 of the square of MB. So we have 1 plus MA over MB equals to Q. Okay, so now we derive the equation that we want to use with the numbers that we have. So as you can see, the first part of this equation is equal to Ka, the kinetic energy that we had in the beginning. So we want to solve for Ka. We just divide this whole thing to the other side. So we're going to have Q over 1 plus MA over MB. Okay, so we know that Q is 6.54 times 10 to the negative 13 divided by 1 plus MA over MB is the percentage that we have right there. So it's going to be 0.0176. And this is going to give us 6.43 times 10 to the negative 13 joules. So the answer that we got is for Ka. So we finished one of the parts. So going to the second part, which is the Kb. To get Kb is to simply subtract what we have with what we got. So we have 6.54 times 10 to the negative 13. We subtract that from what we got right there is 6.43 times 10 to the negative 13. And calculating that, this is going to give us 1.0 1 times 10 to the negative 14 joules. So now we have Ka and Kb. So Ka is the alpha particle, which is part B in the question, and Kb is the recoiling radium nucleus, which is part A. So this is how you solve the question. Thank you.